use logs?
Log 8 over lambda.
That's fine. I just think that's more difficult. But you got the same answer, right? Yes, it's fine. Right, B5. State Snell's law either in words or as an equation. Right, so let's just do it as an equation because we know like words. What's Snell's law as an equation?
Sine 1 over sine 2 equals
Sine I over sine or equals n2 over n1. Now in the exam you have to state what each of the letters mean. I won't do that now because you know it. What's the I? The angle of incidence, which is an angle with the normal. The normal is perpendicular to the boundary between the mediums. And or is the refracted angle, also measured to the normal. The n1 is the refractive index for the first medium, and n2, refractive index for the second medium. Make sure you state that in the exam. Right, B, part, it's a block question. So you have a block of glass, and you have your light coming in at an angle of 40 degrees, and we want to know the angle we get out here. Of course I drew my 40 the wrong way. The angle of 40 is here, and then it comes off here at a different angle. We'll call it x. The air we'll take as 1, and the glass we're told is 1.5. What's the angle? Right, so the formula is sine 40 over sine x equals 1.5 over 1. Easy peasy. Let's try that again. I had it in radian mode. I don't believe you. I'll check though. What did you get? Correct. What is the wavelength? Right, so. No? The wavelength after, not the wavelength before. Now, 6 to 8. Now there is a way to do this because there's different. If you remember, there was different way to write Snell's law. You had sine I over sine or equals n2 over n1. But does anyone remember the other way to write it? Sine I over sine or equals v1 over v2, correct? And what about with the wavelength? You could say wavelength 1 over wavelength 2. So by putting these together, you get this formula. Now, do you know the n1?
Yes.
n2?
Yes.
Wavelength 1?
Yes.
So you can easily get wavelength 2. So we get wavelength 2 will be 6 to 8.3 divided by 1.4 nanometers, which will be 418.9 nanometers is the answer. Does anyone remember the formula for the critical angle? Sine inverse 1, yeah, it'll be 1 over, in this case, 1.5. Actually, this was one of your experiments as well. 41.8. Oh, I actually skipped, that was C, that was actually C part 2. I skipped over C part 1, which was kind of stupid. C part 1 is basically draw a picture of the critical angle. So they want you to describe, huge, I know, 4 marks. They want you to describe how you could measure, listen, they want you to describe how to measure the critical angle using an experiment. You did this experiment. What you do is you have your water tank, and this is the water level. And then what do you have here? You have your laser, and this is measured at 0 degrees, and this is 45 degrees, and this is 90 degrees. And you must, we swing the laser all the way down to the bottom, and we set the laser so that when it hits the water, instead of escaping or coming back in, it just about leaves along the surface. So if you remember, this here will be 0, and this angle here, it should be what I just got, 41.8. No, but since I know it already, I might as well put it in.
Even we got the same thing in our assignment.
This was your lab.
Yeah, no. The one you didn't draw.
I did actually.
You didn't draw.
The graphs.
You said I didn't draw.
Sit back up. Right. Part D.
Part D.
Yeah. So you have your wavelength. It's 6 to 8.3 nanometers, and it goes through the diffraction grating. And we would want the D if for this first order angle the angle is 15 degrees. Right, so what's the formula? N lambda equals D sine theta. So D is N lambda over sine theta. The N is 1, so it's 6 to 8.3 nano divided by sine 15 is the answer. I'm giving it to you now. It's 2.43 micrometers. Which is right. Part 2 is they want the angle between N2 and N3. So first we should calculate the angles and just minus them. So theta is sine inverse N lambda over D. So theta 2 equals, and theta 3 equals, what's my lambda? There it is, there. Is that right? Yeah, that's right, yeah.
30.
Math error.
When did you get the theta 2?
I didn't. I have some math error typed in. Oh, my power's off. Right, so for theta 2, I get 31.14 degrees, and then for theta 3, it's gone. Blasted.
It's 1.1.
Oh no, it's back.
Okay.
What did you get?
Yes, same thing.
50.9 degrees. So 50.9 minus 31.14. So the difference between the second and third angle is 19.8 degrees, which is correct. And lastly, they want the maximum order. So n lambda equals d sine 90. Huh? Isn't that the last part?
Yes.
Yeah. So n is d,
Plus d sine n, right?
yes, d divided by the wavelength, which is 628.
So 90 is 1.
Yes. So here the n is 3.87. So what's the maximum n?
4. 3. 4. 3.
Which?
4.
No, final answer?
4. 3.
Right, the next number is your final answer, and it is?
3.
4.
Yeah!
Yeah, you only have to guess it 10 times. Which is correct. Right, last one, B6.